Good morning, everyone. Thank you for joining. If you'll please bear with me for about 30 seconds, I'll give everyone a chance to move from the hall and into the webinar room. So please bear with me while I watch those numbers go up. Okay, I think we can start. Good morning, good afternoon, ladies and gentlemen. Thank you for joining this webinar co-hosted by WinGD and Envision Energy. My name's Gavin Lipseth. I'm the content manager at WinGD, and I'm delighted to welcome you as we present an update on WinGD ammonia engine technology, Envision green ammonia production, and the key findings from a report into the operating cost impact of green ship fuel using real-world bunker prices, life cycle analysis, and engine performance and emissions data. Before we go any further, let me introduce you to the webinar platform. With more than 700 attendees, we've naturally opted to mute the audience microphones, but you can comment and leave questions in the panel on the right side of your window, or it may be in a separate window. When it comes to the discussion at the end of the webinar, we'll try to get through as many of those questions as we can. So I've just launched a poll that you should see in front of you now to introduce you to the platform. The poll asks you what you as a maritime professional see as the single biggest influence on the uptake of green ammonia. While you answer, let me set some context about how we as an industry find ourselves considering such questions. Since long before the IMO adopted its maritime decarbonisation ambition, it's been clear that green fuels will have to play some role in any such trajectory. Fossil fuels are quite simply unsustainable in the long run for us, for our children, for our planet. But green fuels generated from renewable energy, and in some cases with renewable biogenic carbon, we're only just moving from imagination to prototype production at that point, with variable progress since, pushing those fuels to industrial scale production, global bunker availability, and crucially to competitive affordability against the fuels of today will be a defining challenge on shipping's path to reducing emissions. Today, we're pleased to be able to say that the technology enabling ships to use those fuels is already in place. WinGD already has more than 30 ammonia-fueled XDFA engines on order across a wide range of vessel segments. They join a portfolio that already includes diesel engines, LNG-fueled engines, and engines that can run on methanol and ethanol, covering multiple pathways to decarbonisation. This point is crucial and should be borne in mind as we present the findings of our report focused on green ammonia. WinGD sees its role as providing the engine technology that enables ship owners to meet their own and society's emission reduction targets, using whichever fuel they choose to do so with. The report we're releasing with Envision today shows a path to commercial feasibility for green ammonia. We will aim to do similar work for other pathways and fuels very soon. This is not about promoting one pathway over another, but helping to make the cost and development implications around each pathway fully transparent. So if we look at the poll results so far, we see that 41% believe that the global carbon pricing regime will be the most impactful on the uptake of green ammonia in shipping. The bunkering availability edges between the other three, and proof of operational safety and reduction in production costs still have a fairly high proportion of the vote. So thank you very much for that vote. Hopefully we'll discuss many of those topics, and I'll try and do another poll later in the discussion, maybe see if some of the new information that has been presented today changes your mind. Let me now introduce the speakers for the day. We'll begin with a presentation from Sotiris Topologou, Head of Testing and Validation at WinGD, who'll give an update on XDFA ammonia engine technology. Sotiris will be followed by Frank Yu, Senior Vice President at Envision Energy's hydrogen business, who will talk about the group's existing ammonia production capability, future plans, and price evolution. The result of our joint study into vessel OpEx and green fuels will be summarized in the webinar's final presentation from Benny Hillstrom, Vice President of Market Development at WinGD. All presenters will take part in a panel question and in Q&A, where we will also be joined by Dominic Schneider, CEO of WinGD. So ladies and gentlemen, we hope you enjoy this and find it an informative and useful session. And please don't forget to leave any questions in the panel as we go. So without further ado, let me introduce Sotiris Topologou to come on stage to give our first presentation. Sotiris, over to you.
Kevin, thanks a lot. I'm very excited to be here today and present our latest achievements with our XDFA platform. First, I want to start with engines that have been delivered first, the 52 bore size engines. These engines are for a series of LPG ammonia carriers for Exmor ship management. The engines are built at Hyundai Heavy Industries by AMD and the vessels by Hyundai Mipo Shipyard, again in Korea. We have now been testing the 52 bore size engines for more than 1.5 years. The program started with a first ignition in late 24 and continued throughout 25. Testing took place in parallel both in Winterthur test facilities and the HHI facilities in Korea. A major advantage for us has been that the engines at HHI EMD were available for R&D testing for almost the entire last year, which is, quite frankly, unusual for a production workshop. And this has been only possible because of the strong collaboration we have with Exmor, HHI EMD, HMD, and of course us. We were able to work with a commercial engine in a real-life environment, which allowed us to further test, validate, and refine both the technology and the final product. In parallel, we carried out extensive hazard and HAZOP analysis together with all involved parties and further iterated on our safety and operational concepts. Here, the experience of Exmor with ammonia was especially valuable. What we have demonstrated is very encouraging. We have shown that we have stable ammonia combustion, that the emissions are extremely low, and that we have seamless transfer to and from diesel modes. So overall, the testing has shown that the technology is not only working, but working in a way that is safe, practical, and applicable in real-life operating conditions. Moving on to the next project, our very first 72 bore XDFA engines. These engines are meant for a series of bulk carriers for CMB Tech. These engines are built in China by CSC and the vessels by QPS Shipyard. The engine, which is now under testing in CSC at China, has been fully commissioned in both diesel and ammonia modes only within a few weeks, a strong testament of what can be done with reliable collaboration with our trusted partners. In addition, beside the engine, all key auxiliary systems have also been commissioned, including the ammonia fuel supply systems, fuel valve unit, and the SCR. The R&D test campaign is now almost complete, and the engine performance is fully in line with our expectations. Another step was achieved only this week with a successful completion of the functional integration test, which is another major milestone in the path toward deployment of this technology. Now, moving on to the achievement, to the highlight of all these efforts, an achievement that makes us all who have worked on this project particularly proud. We have successfully completed the first ammonia type approval test and factory acceptance test for our X52 DFA engines. This test took place in late January and early February with the presence of all major classification societies. This was without a doubt an important milestone because it demonstrated not only the expected performance of the engine, but also the successful proof of operational and safety concepts. As part of both the TAT and FAT, the parts inspection was also completed successfully. All inspected components met expectations of all the involved parties. And the key reason for this strong result is that the engine is based on the well-proven X engine platform, which has been specifically updated to accommodate the ammonia-related components. Now, before moving on to the next slides and diving a bit deeper in the detailed measured performance data from these factory tests, the overall message is very clear. WinGD has shown that the technology, our technology, is ready, and we are very much looking forward to seeing this engine sailing in ammonia on the seas. Going a bit more in details about the measured performance data. During the FAT of a 52 DFA engine, all performance targets have been successfully achieved. This strong result is based on the extensive research and development work that began years earlier. Both the measured ammonia fuel and pilot fuel consumption have been according to our official GTT data. And on the right graph, you can see the pilot share energy percentage, which at high loads is at 5%, exactly as expected. And another interesting point is the direct comparison between diesel and ammonia operation. As you can see on the left graph, across the entire load range, ammonia shows better efficiency. So in a nutshell, ammonia combustion is not only cleaner, which I will show in the next slide, but also more effective. And then moving on to something that raised many questions in the beginning of this project. Okay, performance is granted. What about emissions? Emissions were verified again during the official shock test. So these are official measured data, and the results are fully in line with our expectations or even exceeding expectations. The very first trend on the left shows the ammonia slip, which in a word is very, very low. Even the engine out values are well below 60 ppm, and after the SCR, stack out emissions are effectively 0 ppm across the entire load range. In the middle trend, we see also very good results for NOx compliance, both for Tier 2 and Tier 3. And ammonia combustion generally generates less NOx than diesel combustion. Our IMO average is comfortably sitting within the Tier 2 limits, even before SCR. Another important point is N2O, which you see on the far right trend, or laughing gas, which we know is a very potent greenhouse gas. Here as well, the values are very low, consistently below 3 ppm. If we look at the total greenhouse gas picture, the XDFA achieves a greenhouse gas reduction of 90% compared to diesel Tier 2 mode. Overall, the emissions performance confirms that the XDFA technology delivers exactly what it is designed to achieve, a pathway to green shipping. And with this, I conclude my part. Back to you, Gavin.
Fantastic to show progress there right up to this very week in bringing ammonia technology to market. Let me just launch a handout for you for anyone who wants to know more about our XDFA ammonia technology. Appearing in the handouts column should be our ammonia FAQ. Feel free to download and have a read. But first, I'd urge you to listen to Frank Yu, Senior Vice President of Envision Energy Hydrogen. He's going to talk to us about where the green ammonia is actually coming from, how much it will cost, all those important questions you want to know. Frank, thanks for being here. The stage is yours.
Thank you, Kevin. Thank you, everybody, for your participation to this webinar. Let me take 5 minutes to introduce our latest insight about green hydrogen business in the global market. Envision Energy is a green tech company, and is also one of the leading company in the world with full stack technology from the renewable power to green hydrogen and its derivatives. We are the #1 wind turbine company from China in the international market in terms of the annual installation number. Up to now, the total installed capacity of the wind power done by us is more than 100 gigawatts already. So in the green hydrogen market, we position us not an electrolysis OEM only. We define us as the green hydrogen producer and integrated solution provider. To achieve the lower green hydrogen cost is not only about how to reduce the capex of the plant, but also how to improve the conversion rate of the efficiency from the wind power to green molecules. Envision Energy, we use AI technology to develop the weather forecast model and the energy optimization model. These two models can improve the overall energy conversion efficiency 10 or 20% in the operation. Envision Energy will also own in-house technology for the electrolysis and ammonia synthesis. Through integrated solution, we can achieve the competitive cost without subsidy. Our first green ammonia production facility with 100% off-grid configuration and 300K ton per year has been on stream from Q3 of last calendar year. We are selling the green ammonia to both domestic and international market. Bunkering is one of the target market for us. Right now, we believe the coast area of China will be the most competitive location in terms of the green ammonia cost. Although there is still dispute and some argument which green fuel will be more competitive and popular, I want to share some insight with you. The answer is green ammonia. Reason is very clear. Green ammonia can be fully electrified. The whole world energy market is being electrified right now. The product which can be electrified will have faster cost reduction curve as the massive production capacity. Number two reason, green ammonia production, no any carbon. It can be scalable. The green methanol and the e-methane is also good, but the bottleneck will be the biogenic CO2 resource. The green ammonia is not expensive anymore. The price spread between green ammonia and the green ammonia is 150% only right now. In some country or region with CBAM, the green ammonia can be cheaper than green ammonia now. The cost structure of green ammonia is also very stable. Nothing with fossil energy. It can be produced in most of the locations in the world. Without IMO net zero framework adoption, shipping owners are considering LNG. Yes, sounds right. LNG can be a very good bridge product in the unclear situation. While green ammonia can bring lots of certainty to you, the certainty about the price, supply capability, and the future. In the report, you will see later on, it's very clear that OPEX, by using green ammonia, is same as conventional fuel with direct compliance. If there is ZNZ award, the green ammonia will be much more competitive. So our conclusion is green ammonia is not expensive anymore. Green ammonia will bring certainty of the benefits in the future for your shipping port. Thank you very much.
Note that we see that there's a bit of a issue with your slides, but please don't worry. We'll make sure that you, everyone here gets a copy of the slides so they can examine them at your leisure after the webinar. Fascinating here though about the amazing progress in production scaling and your vision for the future of green ammonia as a marine fuel. So thank you very much, Frank. Just a reminder that if you have any questions for any of our panelists, leave them in the comments. We'll do our best to get through them during the panel session. Now, to give our final presentation and the first glimpse of the findings from our joint report, let me call on Benny Hillstrom, Vice President of Market Development at WinGD. Benny, the floor is yours. Oh, I understand that we're having some technical issues with Benny at the moment. So maybe it would be a good time to answer some questions. Maybe I could ask Frank back to the stage if you're there. Thank you, Frank. Let me ask you a question, if I may, on life cycle emissions, while we wait for Benny to resolve his technical problems. So the report that we're going to look at in your Chifeng facility, obviously we've used your life cycle emissions data as well as your bunkering cost data. I wonder if you could tell me, for analysts that are looking at green ammonia globally, what determines the life cycle emissions of green ammonia, and how much can that vary depending on where it's produced?
That's a very good question. I want to share our insight. That's the reason we finally decide we take 100% off-grid configuration to produce green ammonia. China, the grid is very strong. They can provide all kinds of support for ammonia production. But the grid power, the power from the grid still contain quite high percentage of the green electricity, right? If we connect with the grid, sometimes we cannot make sure the carbon intensity in our final product, okay? So that's the reason we decide pick up the challenge, and it goes to the 100% off-grid. So right now, I think our decision is very much right. And with this kind of configuration, even we add up more energy storage systems, and our electrolysis need, fast dynamic performance, and the ammonia synthesis need faster dynamic performance. But overall, our carbon intensity become much lower than the other green ammonia production facility in the world. So carbon intensity is very important. If we cannot maintain the carbon intensity, what's the difference between green ammonia and the blue ammonia and conventional ammonia? Ammonia is ammonia. The only difference is carbon intensity. Okay.
Thank you very much, Frank. While I call Sotiris to the stage and ask him a question, can I just ask you one more while Sotiris prepares himself to come back on stage? We have a question that came through registration from one of the attendees. Maybe I could ask that to you. And it's wanted a little bit know a little bit more about how Envision is positioned in the green ammonia market, and whether you have plans to expand your systems to other regions beyond China. Obviously, you've already established Chifeng. Can you talk any more about scaling beyond China?
That's a very good question. Very good question. So right now, in terms of the overall project execution cost and construction cost, equipment price, we acquired equipment to build a plant. China is still the most competitive location for larger scale green hydrogen project in the world. And very important, coast of China, Japan, Korea, South Asia is also a very big market, okay, in terms of the logistic, supply chain, semiconductor, everything, okay? So, but we are also watching over the other location, like Brazil, like Spain, you see from the news. We want to work with our partners, local partners, to develop a project together in this location, support our partner to produce competitive green molecules, okay?
Great, thank you very much. I see Benny is with us. Can we? I can see you. Are you on sound as well? In which case,
I can see you guys, and hopefully you can hear me now.
Thanks, Frank, for stepping in for an impromptu session. And sorry, Sotiris, I didn't get to ask the question, but we'll come back to that after Benny's presentation. So, Benny, I'll jump off. Glad to have you back with us.
Thank you very much, and very sorry for this small interference, but sometimes technology doesn't actually work as expected. However, thanks for joining us today. Highly appreciated. Today we would like to present and explore some of the future within the marine industry, and how our green pathway may explore and going forward. What we'd like to share with you today is a piece of analysis we carried out to understand the operating economics of future marine fuels, with a particular focus on green ammonia. The goal was to bring together real fuel production and economics, life cycle emission modeling, and actual engine performance data, and then examine how those interact under a plausible future regulatory framework. Ultimately, the question we wanted to answer was simple. What will it take for green ammonia to compete economically with other fuels in shipping? The study combines three different types of insight. First, engine technology. We have two engine types approved with ammonia, and we hold a dozen of orders already, as explained earlier. And we have a fuel consumption data for both on testbed and operational engines. Second, real fuel production experience through the Envision project in the Shifen Net Zero Industrial Park. We have real world data on green ammonia production costs and life cycle emissions. Third, we combine these with fuel economics and regulatory modeling to understand what future vessel operating costs might look like. So rather than modeling fuels or engines in isolation, this work tries to bring those perspectives together to give a more holistic view on things. So, our initial question. This was a question guiding us through the work. What will it take for green ammonia to reach a net cost parity with other fuels in a realistic future scenario? It's important because ammonia has, over the last years, frequently been discussed as a long-term decarbonization fuel. But there is still a lot of uncertainty about when. Also, we saw that in the poll earlier, and whether it becomes economically competitive with today's fossil fuel. So instead of only looking at fuel prices, we looked at a broader operating cost picture, including regulatory costs. And why is maybe obvious, but it's because operating expenses are the lifeblood of shipping economics. They determine not only profitability, but also competitiveness and long-term viability. For ship owners, fuel cost, consumables, emission abatement, and regulatory penalties, they all add up to the bottom line, which is so crucial for all businesses and also for shipping. So how did we actually answer this? To answer that question, we model operating costs for two representative vessel archetypes. We chose a 16,000 TEU container vessel. The reason is they represent the high energy consumption in shipping. And we chose a 210,000 deadweight ton bulk carrier, representing a lower energy intensity vessel. Across these ships, we tested 5 different fuels. We have a VLSFO using our relevant X engine. We have used LNG and eLNG, both using the XDF engine. Green ammonia with our XDFA engine, and the green methanol using our XDFME engine. For each case, we modeled vessel operating profile, engine configurations, fuel and consumable and costs, consumption and costs, and life cycle emissions and regulatory exposure. The result is a comparison of key operating expenditure under different fuels. So, before introducing regulation, it is useful to take a look at what is the cost of today across both vessel types. And the ranking is actually straightforward, as you see from the table. VLSFO is the cheapest, followed by LNG. Green ammonia roughly doubles fuel cost relative to LNG, while green methanol and eLNG are significantly higher still. So if we looked only at fuel cost today, the conventional fuel would clearly win, clearly. The interesting question is what will happen if we then start to introduce a regulatory regime, and how will that change the picture? So we took a look at the IMO net zero framework, which is currently drafted. But the net zero framework has key elements that is undecided yet. Namely the zero or near zero emission fuel reward and surplus values beyond the first 8 years. By not using the zero or near zero rewards and keeping the surplus revenue the same to 2050, we created what we believe is a moderate regulatory regime rather than an aggressive one. The numeric details are highlighted here and are further explained in details in the report. So again, it's trying to give a conservative view of how a regulatory regime could look like going forward. So looking at the first early years of such a regime between 2029 and 2036, in short term, for container vessel, LNG is the most cost competitive option available. That's because the fuel cost advantage still overweights the relatively modest early penalties. Green ammonia comes very close, however, only a few $1 million higher in the period. For bulk carriers, it is a bit different picture. Because fuel consumption is lower, ammonia surplus credits outweigh its higher fuel cost and making it actually the cheapest option. The broader takeaway here is that fuel price still dominates the early economics, and that's why LNG performs well in that period. If we, sorry, that was one slide too early. Now we take the lifetime. So if we take the lifetime perspective and we combine the early and the late periods, we get the lifetime core operating cost comparison. Across the full period, green ammonia delivers a 3 to 8% lower operating cost than LNG. For a container vessel, that translates roughly to $21 million in savings and about $8 million for a bulk carrier. What's interesting is that the separation between fuels really occurs in the later years of the regime, when penalty avoidance become critical. So ammonia competitiveness is driven not by early benefits, by long-term structural cost advantages. CapEx question, the big CapEx question. The crunch question of this analysis raises is about the investment beyond the core OPEX. If ammonia can deliver roughly $20 million of lifetime operating saving versus LNG, or more than $50 million versus VLSFO, what level of additional CapEx is justified for an ammonia-capable vessel? That is still the question. And the current yard prices the answer is not obvious. Those operating savings may partially offset the premium for an ammonia-ready or ammonia-fueled vessel, but they do not it does not make the decision straightforward, especially when you bring in other costs that a switch to ammonia may entail. So ultimately, the transition to green fuels will depend not only on the operating economics, but also on how quickly the cost of both fuel production and vessel technology can come down. So key insights. In conclusion, the OPEX modeling in the WinGD and the Envision white paper demonstrate how green ammonia could become cost-effective of a choice for the cost-conscious and forward-looking ship owner. But more would be needed actually to secure the future. With industrial scale production, supportive policies, and ongoing technology innovation, green ammonia will offer a clear pathway to lower operational expenses, reducing emissions and sustainable growth in shipping. The marine industry has the opportunity to lead the way in decarbonization, driven not by regulations or ethics, but by compelling economics of green ammonia. Thank you.
Thank you very much for that great presentation. I think that hopefully you found that interesting. The analysis, I think, gives us a clear economic framework for understanding where the OPEX, the core OPEX, at least, of using green ammonia and other green fuels could go. For many people in the industry, though, the big question is how this plays out in the real world. Operational readiness, fuel supply, investment decisions. So to dig into some of those questions, as well as a little bit deeper into the research that we conducted, let me please welcome back our presenters, as well as Dominik Schneider, CEO of WinGD, for our panel discussion and answering some of the many questions that I've seen come into the chat panel today. Before I do that, of course, let me put up a new poll, the same poll as at the start, and let's see if we can later on in the panel, if we can see if there's any change in perceptions in this room. So Dominik, thank you very much for joining us, and let me start with you, and we'll talk about the investment dilemma facing ship owners. Building ships today that have to remain cost competitive for 25 years while the fuel landscape is uncertain, that's a big challenge. I wonder if you could share with us, from your conversations with customers, what do you see as some of the biggest misconceptions ship owners still have about the fuel transition, and what are the big discussion points when you go out and have those conversations?
Yeah, thank you, Gavin, and thanks for having me in the panel here as well. Misconceptions, if there was one particularly related to ammonia, was probably the availability, how quick the technology becomes available. That meant rather fast. Within a few years, we actually made this technology available, and I'm confident or sure that the same kind of misconception is also there about availability of green fuel. If we can prove the case that this is possible at an economically viable region, I'm sure this will speed up over the next year. But additionally, I have to say, fundamentally, ship owners, particularly our customers, they're very realistic people and very grounded. And of course, they watch and see a lot. And we have to see now how a higher capex on the shipbuilding side can be justified as well. That's one of the biggest concerns we see. And without economical incentives or things like that, it's probably going to become difficult for some of the owners, but some other owners, of course, they're very eager to move fast and implement the technology as fast as possible.
Yeah, thanks, Dominic. Yeah, I guess that those regulatory incentives come to the fore once again. We gave an example in our findings of how they were how we modelled them. I wonder, Benny, if I can come straight to you if we're talking about that modelling. As you mentioned, it's a fairly tight model that we deployed that focuses deliberately on operating costs and regulation. But there are other variables that could change the economics quite dramatically. I wonder if you could maybe point out what you feel are some of the biggest factors that could materially change that fuel ranking that we presented.
Yeah, for obvious reasons, I think it's also clear in the presentation in the report, fuel costs do have a significant impact, and there are a lot of variation in fuel costs going forward. We are just right now witnessing a heavier increase of oil and gas prices globally due to the crisis we are facing these days. So that is an obvious reason for things can change and change fast. Then we also have what Dominic just mentioned about the capex. Is that being justified? There will be a gap between what we can call a conventional vessel against a modern, sustainable, green operating vessel? That is also something that could change. We have the bunkering cost that is not fully settled, or how much that will be. So that's another uncertainty. And then the IMO regulation or the policies that could influence this. So there are a lot of variables that could change this scenario going forward. And that is the uncertainty we have to live with for now. But that also go for other fuels. I mean, that is not unusual for us being in a business that prices goes up and down, and also consumers are having a tendency to one preference one day and another preference the other day. So I think that's part of the business and part of nature, that things are going up and down. But there are for sure a number of variables that could change this picture, as it's not crystal clear that is a clear winner.
Absolutely, yeah. I think the goal is not to be it's impossible to be all inclusive about cost at this stage of development. So that hint of uncertainty remains. I know, Frank, that you are a very keen advocate that green ammonia helps reduce those uncertainties. And maybe you could talk a little bit about the price evolution that you see for green ammonia. I think we used a current bunkering estimate price in the south coast of China in the report. How do you see that evolving, and how do you see that cost being translatable to other regions?
Okay. Thank you. Yeah, thank you, Gavin. I understand this question. So the cost estimation Gavin used in this report is based on our understanding in this market. That means if you have some vessel, you want to park in one of the ports in east coast of China right now, you sign the order with us, we can deliver at this price. Okay, 100% sure. no any misunderstanding. In the meantime, we do feel China will become a very important country with green fuel supply in the world, because overall, the project cost, capex, opex, is competitive. Okay, actually it's good because a lot of vessels, they pick up product from China or deliver product from the coast of China. Okay, but how to move to the other location? I think this rely on the renewable power cost in different countries, because green ammonia itself can be produced in most of locations. But the very important factor for the cost structure is the capex of the power, upstream power, and the capex of the green hydrogen plant. Right now, different countries have a different cost structure. So sometimes as a company, we cannot control all of them. Okay, so for example, the EPC cost in some countries is totally different as the EPC cost in China. Okay, so that depends the evolution of the different countries. Okay.
Yeah, okay, that's really interesting. Thank you. So it's not, once again, it's something that not necessarily fuel producers, not ship owners, not even fuel producers, not the industry as a whole can really control. It's something that's more structural. Another one of those uncertainties that Benny mentioned, that we'll have to see how that plays out in the future in various markets. Thank you very much for that answer, Frank. So Tiris, let me turn to you, because we've had a few questions on the operational and safety element. One pointing out quite rightly that we can't just limit the conversation to engines and to engine uptake and market. We've got to look at the futures. Let me talk about the operational learning curve that we foresee with the XDFA just entering the market. Every new marine fuel obviously comes with its surprises operationally once ships enter service. Based on what you've seen in testing and early deployments, what part of the operating ammonia engines do you think will, let's say, surprise the operators the most?
Right. So first, allow me to start by saying that the learning curve has been quite steep. 2 years ago, not too long ago, everything was still on a concept phase, and we had only data and concept studies. Everything was still on paper. Now we have already seen how these engines operate. We have experience, hands-on experience with them. And also here, another important aspect is that we didn't start from zero. We didn't start from a white sheet of paper. In its core, the XDFA, it's still a dual fuel engine. And we have been making dual fuel engines since now 10 years, right? So some of the safety concepts, operational concepts were still in place. They just had to be augmented to incorporate the complexity of ammonia as a fuel. So this is a dual fuel engine in its core, of course, changed compared to an LNG engine. And then if you look at the ammonia on its own, ammonia, it's also nothing new for the industry, right? So it's the second most traded commodity. Also in the shipping industry, it's moving around without any issues, right? Having said that, having ammonia as a fuel and as a bunkering trading commodity is something completely different. So what we see and the market is in need of at the moment is training of the crews, without a doubt, and to establish also proper guidelines, proper maintenance procedures. And having all this in place and having also fully automated engine as we have now. So our experience shows that everything operates according to our expectations. We're talking about a safe platform, right? That should be treated not with fear, but only with respect, because it's indeed a new technology, and a proper respect is needed for that.
Thanks very much for that, Tiris. Let's maybe I could ask the entire panel a question that I think is kind of well, first of all, Tiris, to your answer just there. If we look at the poll results on the right, I think you see they have actually shifted. I think that proof of operational safety. Maybe you did a great job with your testing presentation, but that number seems to have gone down. And Frank, likewise, the bunkering availability also seems to have gone down. This may be depending, obviously, polls are polls. But anyway, interesting to see those numbers. But one thing that leaps out there is that over half of the people believe that the global carbon pricing regime system will be the determinant, and that's going to be no surprise to anyone, I guess, especially Dominic. I know you mentioned that in your first answer. So I wonder if you could maybe talk a little bit about what I mean, we know what's happened with the IMO. No one knows what's going to happen with the IMO, I imagine. But do you have any inkling from your discussions and what you've seen around the industry of what would be a sufficient and effective regulatory regime to encourage clean alternatives like green ammonia?
Yeah, thanks. Very good question and the right question. I think it's underestimated or wrongly estimated how the fuel pathways will develop. We will have a multi-fuel future. That's not avoidable. And we talk about ethanol, methanol, ammonia, even LPG to some extent, LNG for sure, and then the traditional fuel. I think the big question is, are these new fuels, more green fuels, replacing the existing energy carriers like low sulfur fuel oil or LNG in the market, or are they coming on top because there's simply a higher demand for energy? That's something to be answered. So there will be a multi-fuel future for quite a while, and that's certain. Now, which fuel will prevail? That's crystal ball. But of course, the carbon pricing, which is also nicely shown in the study done, will have an effect on that, because at the end of the day, and it was mentioned before during the presentation, at the end of the day, ship owners are very pragmatic. It's going to be economical. It must be economical. It must be business viable. Otherwise, it will never survive. And there only regulation can step in. Now, of course, the IMO net zero framework is in place to make a global standard. Does it come in October? Who knows? If it doesn't come, I expect sooner or later other regions than just Europe to come up with own regulations, with own taxations, hopefully following to some extent the proposal of IMO in a reasonable way. So we do have somehow a global standard. But we have some regions in this world, very strong regions, be it China, be it Oceanic, Australia, New Zealand, and so quite sure they consider to have carbon taxes. In China, it's also, as Frank correctly said, they are building up very fast this green fuel supply, and of course they want to have incentive to export this fuel or use this fuel. So I would be surprised if not within the next 2-3 years, if the net zero framework fails, if there would not be some regional, more than just fuel EU regulations. So that will come to some extent for sure. Yeah, and that will then help to drive the development of the fuels. And again, which fuel is most viable depends on the economics, availability, and the technology availability. But I think on the technology side, we made a big step. On the availability side, big steps are done in some regions. In some other regions, investments are on hold. That will balance out over time, I'm quite sure. And it's going to go the right direction. I'm quite confident there.
Thank you, Dominic. So Thierry, there are a couple of technical questions here that I think have your name on them, and maybe we could jump into those now before coming back into some of the market and fuel fundamentals. One was very simple. You'll be able to clear it up simply, I hope. About the in your presentation, you presented the test emissions on an engine out and exhaust out basis. Can you just clarify what you mean by that?
Yeah, sure. So what we measure actually in the workshop is the exhaust emissions upstream the SCR and downstream the SCR for comparison, and also to improve our tuning strategy. And what I showed before in the trend was both values. So below 60 ppm means engine out before SCR, and 0 ppm means downstream SCR. And this was without active urea injection, but rather with passive mode SCR, means even lower OPEX for these engines. And in reality, we would not even need an SCR for for this ammonia, which is very, very limited ammonia slip. But because we want to cover all the years to come and all possible scenarios, and of course also the ever-expanding emission regulations and legislation, we install SCR on all our XDFA engines.
Great, thanks for that, Satiris. The other question that's very practical in nature is about lubricating oils and ammonia engines. I think that was a general question about what are the considerations to bear in mind when you're lubricating.
Yeah. Sure. So regarding lubricating oils, if we're talking about cylinder oils, we are suggesting BN40 oils, and this is already in our website, so everyone is welcome to go up and look at our validated oil. And then when it comes to system oil, any oil practically can be used, because in our engines, due to our technology, we don't mix oil, or we have no interconnection between the system oil and ammonia. We are sealing everything either with sealings or with air. So there is no connection between system oil and ammonia.
Great, thank you very much. Let's talk a little bit about methanol. There's been a couple of questions that have come in there. I think one surprise was that the gap between methanol and green ammonia is so high. One question asks, if that's the case, why are there so many methanol fueled ships coming into service? Which I suppose is a good question. There's no doubt the methanol fleet has grown quite dramatically over the last few years, and I guess the ammonia one is fledgling, and that's partly because the technology is only just being introduced. But maybe Dominic and Benny, you could talk to that, why you think that that fuel's growing, whereas we see green methanol as in our modelling as not being quite as attractive.
Yeah, I'm happy to try to answer that one. A few years back, when methanol was introduced as a fuel and vessels was starting to be built for the uses of methanol, there was a high hope that production scale would bring down cost significantly at a much greater speed than we have realized today. Many of these, and now I'm maybe guessing a little bit, many of these production plants have maybe been very optimistic about how fast they could scale up. So the availability of green methanol is still limited. And that's maybe where the production and delivery of methanol fueled vessels have overtaken the race compared to what can be produced as we speak. So I think that's the primary reason why you still have this high cost of methanol, because there is a limited availability still.
Interesting. Thank you very much.
Maybe allow another comment here, and actually Frank would be better suited for this, but to produce green methanol from hydrogen, and I'm not talking about bio feedstock, but hydrogen feedstock, the process to produce methanol or ethanol from green hydrogen is more demanding than the process to produce ammonia, and that's of course then also reflected in the costs of the fuel. I think that's also an important factor.
I can comment something here from a perspective, from a fuel producer view. Methanol, I think, why the methanol vessel right now is much more than ammonia vessel, because supply chain, right, to logistic to deliver methanol. Methanol is a very big commodity, same volume as ammonia in the world, very big feedstock for all kind of chemical process. So the infrastructure supply chain compared with ammonia is much more popular. For example, store the methanol in the port area, it's compared with ammonia, it's very easy. Okay, very easy. So this is one reason. Another reason is, compared with ammonia, the toxic level of the methanol is less. So it's a good thing. So, and in the engine technology, methanol engine is mature or advanced than ammonia engine. That's another reason. So drive the shipping owner take the easy way, okay, to go to the methanol. But the problem is, please bear in mind, I bet green ammonia, because methanol, the cost-wise, have a carbon. Another, the methanol ethanol is a good feedstock for the SAF. SAF has much more margin compared with marine fuel. Okay, if ethanol is there, why go to the bunkering? Should
SAF
we go to
being the sustainable aviation fuel.
Yeah, it's the price is much higher. So, but the ammonia cannot go to the SAF. So finally, I think from the cost perspective, the shipping line should get the lower cost fuel as lower as possible. So
Great.
Time will tell. Nobody can guarantee. I bet green ammonia. Thank you.
Thank you very much, Frank. Well, that takes us to the hour, just after actually. So apologies. Just to let everyone know, thank you very much for joining us. We hope you found this instructive. You will be receiving the report directly by email straight after this webinar. There are a few other questions about regulatory regimes, other fuels, and we really hope to be in touch with you in the future with more of this kind of work, showing the way forward on OpEx for clean fuels for the maritime industry. Having said that, thank you very much, Darius, Frank, Dominic, and Benny for joining me. And if you can join me in saying thank you and so long for now to our audience. Thanks for joining us.
Thank you, and have a good day. Thanks.
Bye-bye.
Good day.
Bye.
Thanks, everyone.
Bye.